Hi,
Hello. Hey.
how's it going?
Good. How are you?
Doing good, doing good. All right, you ready to jump on in?
Yeah, let's do this.
Okay. Just a really quick question about your background. Like, this isn't really too much. The question I have isn't too heavy in programming, but just what kind of programming languages are you comfortable with? Just to get an idea.
Uh, Python would be my favorite. A little bit of JavaScript.
Okay,
Um,
perfect. All right. So today, I'm going to ask you a question about data munging and uh, well, let's just stick with that. Last quick question: do you understand the fundamentals of baseball, like the mechanics of innings and batters and pitchers and stuff like that?
uh, Probably I'm gonna go with no.
No.
Uh,
Okay.
yeah, I know very, very little about baseball. It depends on how fundamental. I know there's like 9 innings. Um,
Okay.
there's four bases and stuff like that.
Okay.
But
Then I think that's all. That's all we need. We don't we certainly we're not going to get too crazy into it. But yeah, if you know that there's 9 innings and 4 bases, that's all we need.
all right.
So basically, what's happened to set the tone. So you've just started to work at a new startup that's called Internet Baseball Database, and their customers have started to complain that the features aren't very good and that the site is really slow. So you've been told to come on in and kind of help clean everything up. So the idea is that this company gets a regular data feed from Major League Baseball that has data that they're going to want to display on their site. And can you read what I'm typing here? Like
Yep, I see. Hi.
yeah, okay. So basically, what they are sending every day is an update of what happened in each of the baseball games. So it's a very simple text file with tabs, and it's going to have just column fields, and it's going to say it's going to have the date that the game was played, the home team, the away team, and every column actually is going to be an at bat. So it's going to have the batter, and for right now, we'll just say the results, like the outcome. So an example here might be like today's game would be on the 26th. The home team was the Giants, and the away team was the A's, and the batter was Coco Crisp, and the outcome was that he got a single. So the outcomes will be like S is a single, which counts as a hit. D is a double, which is a hit. T is a triple. It's H, the home run, the hit. And then there's also K is a strikeout, which is not a hit, which is no hit. And F would be a fly out, something like that. So there's sort of like a little code for what happened, and what the site currently, how it works is that you get this text file every day that contains all of these like lines, and the owner of the site is very paranoid, so he doesn't want to put it into a database because he thinks that database people are out to get him. So he just stores it on the file system. So he'll have sort of on the file system, he'll say data, and then he'll put the year, and then he'll put the day, and then he'll just have the data for that day. And when you the other thing is that he also is very paranoid and doesn't trust file system developers. So he invented his own file system that's very inefficient and can only hold 1,000 files in every directory. So that's why he can't just put the date like this, because at some point there'll be too many directories or files underneath this directory. So he has to kind of split it up this way. And when someone comes to the site, they can, right now, the only thing they can do is they can look up a certain date, and they'll get all of the information for the games played on that day. But he started to get some comments that wouldn't it be nice to look up other things? So for example, wouldn't it be great if you could just look up a particular player and see some of the stats for that player? And as you might imagine, using this technique of storing the data, that's a bit inefficient. So your task in a sort of a larger, like overall task, is to come up with a way, given these constraints, that you have to store the data in flat files on the file system, and no more than 1,000 per directory and that kind of thing. Find some way to represent the data that would enable searching for, say, a particular player and getting some statistics based on that.
Okay. So quick question: if you were to reorganize some of the data, so it's like something like this, would that directory probably have more than 1,000 entries at some point? Because
it would, because this is all of baseball for the 100 years that they've been playing. So there's a few too many.
All right.
And specifically, just so that's just the overall thing, and then the specific sort of feature that we'd like to do is we'd like to be able to calculate or show on the site their batting average. So the batting average is the number of times that they went to bat divided by, or the number of times that they got a hit divided by the total times that they went up to bat.
Is that the only thing we'd like to find about these people?
For now, I mean, I think if you can get that far, then I think the other ones would sort of come naturally, and this kind of, I think, brings out the core of where the challenges are. So let's just for this exercise just explain how you would calculate the batting average.
Okay. So another question is something like a file like this that would have each row being a player and his batting average. That would have a lot of rows, but is there any limitation on the size of that file?
No, that's okay. That's okay. So, and I see where you're going with that. That's true that you could just create a single file that has all the batting averages. And then if that's all the things that you're looking for, then that's pretty good. The one thing that I might say about that is that if you were going to create that file, it would have one row for every player, right?
Yes.
So then how long is it? How long would it take to look up a player in that dictionary?
The size of the file, like where if n is the size of the file, it would take order n.
Right. So if we have hundreds of thousands of players, and maybe it's not a very efficient file system, maybe that's also going to be a little bit slow, because you'd have to scan the entire file and then do a search on it, and then. But yeah, that's a good start. That's a good. I mean, certainly in the database world, you would just create like an aggregate table like batting averages or something, and then you could just look it up right away. But I think for this exercise, do you think there's a better way to do it that wouldn't involve having to read in the entire file?
Okay. So now my next idea, that makes sense, if that's going to be a lot of players. It's kind of looking like a RESTful API where like each file, so there's like, you could look through all of the players and like, so this is player/1.txt, which isn't terribly informative, and we'll have like 1,000 players per each of these files. And it's a kind of, ideally, I'd want to say sorted by name, but then that doesn't work when you're inserting. You don't maintain the sort, so that's not good. I mean, then you have to change everything potentially.
Well, so the updates are not necessarily such a big problem because so you're getting one of these files every day, and so it's possible to just do one big offline update at like once a day. Like that's not such a big problem. But I'm interested in how you are. So the idea would be that you'd have 1,000 text files, and each text file would have the batting average, let's say, of the individual files.
Yeah, sorry. So
then,
this is.
Oh, okay.
Yeah, sorry. So it's just each one of those, the players folder is just like so let's start, we're trying to look up by batting average. And then the only reason we have a subdirectory is like, ideally we'd want it all in one players folder, but you can only have 1,000 subfiles. So that's where the 1-2 directory comes from. So then you get 1,000 squared. Inside of here is a player name. Is that, yeah, like something like that. And then, so you get 1,000 players in the first directory and 1,000 players in the second directory. And then the speed up bonus comes up by if it was like alphabetized or a decent, I mean, I don't know how many players there are, but a decent way to do it would just be to default to like 26 folders where each one is a letter. And so it allows for like expansion. If a new player joins the game with like another A, there's only like 500 players for like first name or last name, depending on how you start this, that start with A. So you could just like insert it into that same folder structure, and it won't require like making something different.
Okay. So instead of, so I see you've written 1 and 2 here. So you're saying that you could do A, B. Right. Okay. So then what happens when there's more than 1,000 people with the first letter A?
Yeah. So if that was an issue, then you're going to have to do something like A1 and A2, and you're going to have to search through all of these files, which is, it's kind of annoying, but to find the player that you're looking for.
So if someone comes in and they're named Anthony, you first open A1. You do a search through the directory to see in A1 to see if the name is there. Then you do a search through the directory A2 and see if they're there.
Yeah, that's what I was getting for.
Okay. There's even a little bit faster way to do that search. Even in this way. So that's a linear sort of scan. Is there even a little bit faster way to do that one?
Typically, when you're saying faster than linear, I'm thinking binary. And if it's sorted, you can kind of do a binary search.
Right.
So, I mean, yeah, you could do that. You could try and you could still do a binary search with all the players on A. And you'd know immediately whether it's in A1 by just checking the last value in A1.
Right.
And then you could just go to A2 and find it there. So that'd be a faster way to do it.
But that's not exactly a binary search. So like if you had like
sorry, so I guess I didn't describe the binary.
Right. Yeah. Like if you had 3, 4, 5, 6, 7,
Yeah.
it still would be like, I think if I'm understanding what you described, so you would look at the last letter of the A1, and if that was too small, then you would go on to A2 and look at the last player on A2 kind of thing?
Kind of, yeah.
Okay. So technically a binary search would be going from A1 to A4 and then looking at A4, and then you would decide, do you want to go back to A3 or forward to A5 kind of thing?
Yeah, you're right. So I guess, I mean, I kind of considered like the number of A's in this directory would be such a very small constant number.
Mm-hmm.
I mean, it's easy enough to just check the last value in each one. And then if you're trying to make it a faster lookup within, even a lookup of just 1,000 names is relatively fast. But if you wanted to make it faster than that, of those 1,000, you can do a binary search where you check you check the middle and you decide whether to go up or down.
Okay.
So yeah, it wasn't a true binary. You could do a true binary by checking A4 and going up and down, but you probably wouldn't even notice the time you saved.
Right. No, that's a good point. That's a good point. So if we're probably thinking about somewhere on the order of hundreds of thousands of players, then once you get down to these individual ones, it's probably doesn't make as much of a difference. But let's say for argument's sake that this guy who wrote his own file system, he did it terribly inefficiently, and even just looking up just doing a search over all of the directories, like getting a list of all of the directories in subdirectories inside a directory is really slow. So we wanted to still optimize that so that you are doing as few possible sort of linear scans of these directories. So
yeah.
It's basically okay to try to say, I know this is the name of the directory and give me its contents, but doing the search through all of them is a bit slow. And also, it does kind of touch a lot of different pieces of disk to actually have to say, well, what's the name of this file, this file, this file, and so forth. So is there a way? So, and basically this is kind of getting at it's an interesting hybrid, because on the one hand, the splitting up of the A, B, and C is sort of very targeted and going directly to a place that you want to go. And then the second half is more like a linear scan kind of thing. Is there a way to get this so that it is all of the first one and none of the second one?
Yeah, no linear scan. So we're definitely gonna keep this sorted thing.
Well, do you though?
If we're not trying to do a linear scan,
right? So I mean, so it just if you think about it, I mean, you're really on the right path with the ABC thing. So where did you get that? And in general, what is that technique sort of called when you have some kind of value and you're putting them into buckets according to some kind of attribute that they have? So in this case, you have the players' names, you have a bunch of different players' names, and then you're sorting them into the buckets like A, B, C based on the first letter of their name.
Yeah.
So how is that? So can we generalize that a little bit and make it so that it works even after 26 letters and being able to and then you don't have to worry about the fact that there's very few players whose names start with the letter Y, but very many that start with T or something like that.
Yeah. I'm not sure what it's called, but yeah, what we're doing, we're taking attributes that we know and kind of filtering on that and making those giving them buckets. I mean, that's the idea of it.
Yeah.
Giving it buckets. Um, so should we be looking for like a better bucket system?
Well, I mean, so this bucket system is not so bad. It's just that it um, like it still requires a certain amount, like it requires some sort of post processing, you might say, it's a little bit too fine grained, or it doesn't it gets us part of the way, but doesn't take us all of the way. So
Hmm.
how about this? How about we say in the spirit of divide and conquer. So when you first started, you just had you had this big group of names, and they all were different names, and you put them into 26 buckets.
Yeah.
Now let's go into a bucket. Now you can sort of think of it as, now it's the same problem again. You have a bunch of names, there's too many of them. How do you split them up?
By we have too many names.
So like the T, for example, um, it has um, it has too many. Like there's more than 1,000 players whose first name just a T. So now you have a bunch of names. They're all sort
Yeah.
of related a little bit in that they all start with letter T,
Yeah.
but there's more than 1,000 of them. So you have to find some way to find more buckets to put them in.
Yeah. So this is a little bit of a shift, but now so I was thinking something like team name, uh, players, player name. So that I mean that will narrow down our buckets. So you probably wouldn't have like at this point player name.txt. You're probably good to go. The only thing is the first thing comes to mind if like a player switches teams, I don't know where they're going to be.
But also, like, think about the UI. So in the UI, we're just looking up the player name. We don't know what team they are necessarily. In this database, how would you, if this was the only data source that you had, how would you look
Uh,
up the team name?
I would hope there'd be a function that maps player to team. But if that doesn't exist, then yeah, you
Yeah, I
can't do
mean,
that.
you could certainly you could write one, but like this, like sort of the um, the data we're looking at is the one source of data that you have. And I mean, you could add new files and you can do stuff like that, but there's no sort of magic uh, like external source of data that's going to give you that. I mean, you could obviously look it up, but
Yeah,
it would probably be a very expensive operation using that original sort of data format to look up what team a player is on.
get it. So that's other things that I can think of, like other attributes on the player. Is I mean, it's their batting average that we're looking for.
Mm-hmm.
But I'm a little ambiguous of why that would be a good binning structure. Oh, I don't. I mean, it's like there's
All right, well,
more than.
okay,
Go ahead.
here's it. So in all the letter A's, those are players whose first name starts with A. What
Yep.
about their second letter in their name?
Oh, got it. Yeah. Uh, yeah, that would be a fairly reasonable way to sort until you had less than 1,000. And I
Right.
mean, reasonably so, like more than 1,000 players having the first two letters, or maybe three letters, whatever it is.
Yeah.
Seems to work pretty well. Um, so yeah, so now there's two ways to do this, right? You could do like first letter and then second letter and then third letter as all different directories.
Mm-hmm.
Or you could just do all three letters as one directory. I think it's I mean, I don't know. So benefits. You said you want to minimize directory calls, right? Like going down directories.
Right.
Yeah, it seems reasonable to like, you could look up a player with his name and you could find a directory really fast with just like this structure,
Mm-hmm.
where there's multiple directories of two or three lettered names.
Mm-hmm.
And I'm not sure which would, I mean, yeah, I'm not sure which would be better. And then inside of here would be player name.
Right.
That starts with like ANT player name.
Right. Okay. I mean, so the things that I'm thinking of, so with the ANT, one of the benefits, like you said, is that you have fewer hops that you're going down and that you're making calls to the system. But there's one slight disadvantage in that, again, it's possible because 26, there's 26 letters, 26 to the third is greater than 1,000. So it's possible that, again, there's there might still be too many. And then, it might be one of those things where you set something up that works at first, and then at some point, as the number of players grows over time, then you hit this weird bug that's kind of somewhat difficult to diagnose and maybe difficult to fix at that point. So that's sort of, I mean, there's definitely trade-offs in that. But yeah, that's basically the idea. So here's the next challenge that so let's just say we're going to move forward with this, and sorry about that. And now we want to actually go ahead and compute this, and we'll say for the time being that we're going to do everything is in an offline mode, where every day we're going to get this new data file, and we're going to recreate this player's subdirectory like you have it here.
Okay.
And granted, the size of this file is even all of these put together is probably not that extremely much, but let's just say that our data center is extremely resource poor, and it has low amounts of RAM and very little disk space, and the CPUs are really slow. So, but we have a ton of them. That what our fearless CEO did was he got bargain basement prices on a ton of really crappy computers that are really slow. So how can you think of a way that you could produce this file or this directory structure in such a way that it could be parallelized across all of these sort of low-powered machines? Yeah. And you think, after thinking it through, that you might even want to change exactly how this is working, like how you want to do it, then that's sort of fine. And just to clarify, so when you have ant player name text, so this is actually, you'll have one file per person, or you're talking about there would still be one file with multiple people in it?
No. This is one file per person.
Per person, okay.
Yeah. Yeah. So really quick, I'm not completely positive I understood the question actually, but how do we parallelize the lookup? Is that it, or is it
no, how do we parallelize the batch data processing job that's going to happen every night that will produce this player's directory? So the player's directory is only valid for that one day.
Yep.
And then at the end of the day, you get a text file, then the next one, and you need to update it. So yep. There's two ways to do it. One, you could update it in sort of an online fashion, where you could go and you could take every row of the file and go and update that thing. Or the other way is that you just take the sum total of all of the files and recreate that player's directory from scratch. Okay. So let's just assume for right now that we're going to do the latter. We're going to throw away the player's directory, the derived directory, and we're going to, just given that first set of data files here, and we're going to recreate the players directory for the next day.
Okay, and we want to try and do this with a parallelized. Okay.
But just sort of general, like, I don't know if you're familiar with any of these, like Hadoop or MapReduce kinds of things, or just if you can think of some generic kind of way of parallelizing this across sort of many machines.
Yeah.
Either way.
Okay, so all right, I guess thinking in terms of like mapping and reducing. I mean, reducing, we're trying to reduce all of the players with the same name and their batting average, assuming at least like independent, unique names. Mapping, we're mapping the player and whether they hit or didn't hit. Sorry, so batting average is hits versus total hits.
Yeah.
Our total attempts.
Total at-bats, yeah. Mm-hmm.
Yep. So if you were mapping all of that, you get the total attempts. You could do. So you can map this to. Let's see.
So if you're not super familiar with like the MapReduce kind of methodology, you can just sort of explain it in generic terms, not necessarily. I mean, MapReduce is certainly one common way to do it, and that would be certainly a valid way to do this. But just it doesn't have to be limited to that.
Okay, yeah, I'll go a little higher level then. So each computer, I guess we have these data files like this, so each computer can grab a data file, and it's trying to look for like all the instances of a player. So, because we have atomic by day. I guess, I mean, so yeah, how the easiest way, like a whole, like if you had an army of computers, is each army of a computer can like operate on a single day and come up with like a batting average per individual per that day, and then we need to take that like intermediary, and then we need to sum up. We need to do that operation, combining essentially all of combining them on their unique names, and then I guess averaging their batting average for each day. And then once that operation is done, you recreate a data structure or file system. So yeah, I'm going to write out a pipeline or something. Okay. So a computer operates on a single day, and it wants to try and compute all the players' batting average for that day. Let's say like we save that to an intermediate file. And so now we have a lot of intermediate files.
That's fine. There could be a lot of intermediate files.
And each one will have, so now we need to combine on name. How can we do that? Parallelized. We can, I guess maybe the best way to do it would be to like save. So like once you've calculated a batting average for that day, you go to the place where that guy is saved on disk, and we update his batting average. And if he doesn't exist, we insert it. And if he does exist, then we update it. So updating will be an average of what currently exists and the current one for the day. But then we also need to keep track of how many days we've updated him, because like if he's done 99 days really well, that should be weighted heavier. That makes it. I don't like that last bit.
Yeah, so this is really close. This is really like a good progress. The one question that I have is, so like let's say that one guy has a batting average of 0.5 today, and he has a batting average of 0.3 yesterday. Does that necessarily, like, what's his batting average over the course of these 2 days? Is it the average of those two numbers, or is it something else?
No, it's total hits versus total attempts.
Right.
And so what we can store instead of batting average is actually like hits over attempts.
Okay.
So it's person, like it'll be a mapping of person to hits over attempts, and then now we can have multiple processes saving saving this if it doesn't exist for a person, and then if it does, just updating the hits over attempts values, and then this can also, after that's been updated, can calculate like a new batting average.
Okay.
I mean, which is that value.
Okay, that sounds good. Now, so this gets into an interesting question having to do with so you're sort of incrementally building up these players files as but all in parallel. Now, if we one thing that is not available in this file system, and actually is that true for a lot of file systems, is that locking the shared file system from multiple machines can't be done reliably. So it's possible that if you're having multiple machines working at the same time and they're trying to update this file at the same time, that the data could get corrupted. So can you think of a way that you can build up these intermediate files, which is definitely the right way to go, in such a way that you're not going to have multiple machines trying to read and write from the same file at the same time?
Yeah. So you know how back up here I had it was just a single player name .txt. Mm-hmm. So yeah, I guess like I don't know if this value would be less than 1,000, but like each file instead of updating the single file, there's now 1,000 files here, and so each this would restructure the directory to be unique, which then it would look a little more like a tree. So it's like A/N/T, if that was his name, and then his player name, and then like the day one. And essentially each file just saves to this directory structure.
Okay.
And then, at some point you're going to have to do a computation and combine them all, or you could do that. Yeah, that's where at the end you'll have to combine them all.
Okay.
And then, that's over the locking problem.
Yeah, no, that's exactly it. And in fact, you've just laid out the map and the reduce steps. So this step here, where you create player name _state, that's the map step. And then the reduce step is after all the mapping is done, for each one of these directories, you read all of them and combine the total hits versus the total attempts.
Got it. Yep. I see that.
That's it. So yeah, no, I thought that was really good. That was definitely along the lines of what I was thinking of for this. The only other thing I'll just point out here, this concept of the bucketing and taking like a value and putting them into buckets is generally called hashing. And that technique is something that you'll hear a lot of people asking questions about in these kinds of interviews. That hashing and hash tables and hash maps and all this kind of thing is something that comes up quite a lot. And you were definitely on the right track with the ABC thing. And this sort of hierarchical thing is interesting, and that's definitely the way that these things tend to go. Another way that you could do it, just sort of to throw it out there, is that there's some pretty standard techniques for turning strings, like people's names, into long series of numbers. Like it would just take the name, Cocoa Crisp, and it would turn it into the number like 7,482 or some 64-bit number or some whatever. And those are called hash functions. And that's another way that you could do it that actually helps to alleviate this problem of the like many players in the A and the T and not very few players in the Y and the Z. So that way it kind of evens things out a little bit. But
I know. I'm fairly familiar with hashing, but I never really thought about hashing and then saving on a file structure. Like
it is a little bit different way of thinking about it, but you'll actually see that this kind of technique shows up in all kinds of things. Like where you most often see it in things like memory, that like you're just trying to find an index into array. That's sort of the most common one. But this is an example of another application of it where it can actually be quite handy. So, but yeah, no, I thought you did great. Did you have any last questions?
No, this is awesome. This is really interesting. Yeah, thanks so much for taking time to do this.
Cool. All right. Take care, man.
Bye-bye, man.
Hey, bye.